Are you able to see the screen?
Yes.
Okay. Okay. So, uh, Alhamdulillah, we come a long way in our semester, and we're almost finishing week 13 today. We started our journey with the basic understanding about object-oriented systems with concepts of abstraction, encapsulation, inheritance, and polymorphism. Then we had a look at architectures and different kind of architectures we have, and some of those applications of the architectures as well. And then we had a look at how we can design packages, and then we had a look at solid principles, design patterns lately. And in the last lecture, we talked about refactoring, and we finished the concept of refactoring. So this brings us to the last concept or topic of our course, which is software construction. And just to help you guys, again, visualize with me, let me refer back to the same diagram I showed you probably in week 3rd or 4th, where, you had the design patterns at the bottom. And then you have the architectural styles on the top of it, and so on and so forth. We're somewhere here. So, and if you recall, we had 2 levels of design. One was the high level design, which was basically your architectures, and then we have the low level design, basically which was basically all about the classes and then their interfaces, the abstract classes, using the solid principles and design patterns. So the last thing we're going to talk about now is again something which is very specific, very interesting from a design perspective, and it's very important for us to understand it. And it's something which is very close to the source code now. Right. So if you look, we have done the journey from high level details all to the way to the low level design decisions. So ready for this one? Then a different design, another aspect of design.
Yes, inshallah.
Inshallah, not hard at all, but I believe is very useful. So we're going to have a look at a few things as part of this lecture. Probably will not be able to finish the whole lecture today, of course. We'll continue the same topic on Sunday. But we're going to start off with the snapshot diagrams. Probably no one has heard about them, correct?
No.
That's fine. That's inshallah what we're going to use and learn. They're very easy, by the way. Then we're going to look at why specifications, and probably we'll stop somewhere here today. Specification structures and how they look like, and different examples of them. Inshallah, we'll continue this next week. Right? So let's look at what are the meaning of snapshot diagrams. So snapshot diagrams basically represent the internal state of a program at runtime. Okay. And basically, as a designer, you have to sometimes understand and worry about, the state of a program at runtime and how it's behaving and what kind of, memory resources it's using and so on and so forth. So snapshot diagrams basically, again, graphically show you or help you graphically represent internal state of a program at a runtime. And we use snapshot diagrams for many reasons. Of course, the very first one is that diagram speaks 1,000 words in a sense, so we use them for our communication, for our team meetings, for our discussion as software engineers and designers. But what we really use it for within these meetings or discussions, we basically use them to illustrate or demonstrate the concepts like, the primitive types and object types, or immutable values versus immutable references. And we use them also for abstraction and concrete representations. All right. Have you heard about any of this stuff? Primitive types and object types? I'm pretty sure you have.
Yes.
Right. So what are the primitive types?
Like integer.
Like integer, exactly. And what could be the examples of object types then?
The object we made ourselves.
The objects we create ourselves. Are there any data types which are, not primitive types, but, they are more like, strings?
It's a
Yes,
string, I
exactly.
believe.
Exactly, exactly. So this is something you guys know, but I'm gonna try and help you guys represent it and understand them in a slightly different way today, inshallah. Right? Using these concepts. So do you know these concepts, immutable values and immutable references or mutable values? Probably no, right?
Yes, maybe no.
That's fine, absolutely fine. So let's dig into it. Now, first of all, easy stuff. We all know primitive values. They are something, uh, which represent a certain value of a certain variable. And in a snapshot diagram, we usually represent them with the number itself, the value itself, and an arrow coming in it, or with the help of an arrow. So basically, it's just telling me what? It's telling me that, this is a primitive data type, three, value of three, a float, a character, or null, and so on and so forth. So far, so good?
Yes.
Easy stuff. Now, let's look at the objects now. Now, objects, usually in a snapshot diagram, we represent objects using a circle or an oval. And we can write more details about objects within the snapshot diagram, where we can, write the field names, we can show the arrows pointing out their values, and we can also even give more detail by telling, their data types and so on and so forth, right? Of course, it depends on what level of snapshot diagram you want to draw and what level of details you want to show. But a typical snapshot diagram will look one of these three. So what is this telling me? When you look at this diagram, what tells you? What you believe is these diagrams depicting? Anybody would like to try?
Maybe representing the values that like the values representing the object. Maybe this
Absolutely.
object is a point. It's
Mm,
a point already, and
mm,
the coordinate. So
mm,
there is x and y, and
mm.
it's illustrating values.
Absolutely, so you're spot on. So basically, this snapshot is telling me that I have an object called point. Now, I can, do with this if I don't want more details to be represented, or I can give more details and saying object point, same object, right? But it has two variables or coordinates, in this case x and y, and their values are 5 and -3, right? Or I can give even more details, and I can still provide more detail by saying, these x is an integer, y is an integer, so on and so forth, right? So graphically, by looking at these, we're talking about the same point here, but the level of details are different. And we already know that, these are your primitive values. So it just tells you that these are primitive values and their data types, for example, and the actual values it has at a runtime. So far, so good?
Yes.
Yes.
Great, great. Easy stuff. Now, the reason I start with this is because I want to use actually, and I want you to understand this concept, which is the concept of mutable and immutable values. All right. Now, what's the meaning of the word mutable? First of all, so if you define mutable in Google, can someone do it? Quickly. Define
Okay.
mute. Yeah.
It's multiplication.
Multiplication, yeah. Let's see what Google says. Mutate.
And changing over time.
Yep. Yeah. So it says change in form or in nature, right? I just did a Google on it. It says change in form or nature. Okay. So mutate means something which is going to change, right? Now, we're going to look at this concept of muting values or reassigning variables, and you know how we can use snapshots to represent it. So snapshot actually diagrams, the one we just seen, you know, help us visualize the distinction between the changing a variable and changing a value. So sometimes what can what you really can do as a programmer, and you know, which eventually makes interest for you as a designer, is that when you assign a variable or a field, you are actually changing the variable points to. You can point it to a different value, right? And on the other hand, when you're assigning the content of a mutable value, such as an array on a list, you can change the reference inside the value. Now, before I proceed, I want you guys to read these 2 bullet points for me individually, please. Take a moment and I want you to read these 2 ones for me, please, before you and I move forward. Please kindly go ahead, try to read these 2 bullet points. And let's have a discussion on what you get out of these 2 bullet points. So what do you think, guys? What I'm saying here?
I believe that what I understand from these 2 points, that the values, you can change the arrow. Okay, you didn't change the value. You change the arrow, just that.
Or the location, right?
The location, yeah. And you are not like pointing at the value or pointing at the reference of the value.
True, true, true. Anybody else will like to share his understanding of these 2 points?
What I understand that when you assign to a variable, you are changing the pointer where it's point to.
Correct,
But
correct.
with immutable value, you are changing the reference, not the pointer.
Correct, correct. So sometimes you will be changing the location, right? And sometimes you will not be changing the location, but you will changing the value within the same location, right?
Yes.
That's the point. Everybody got this one? Anybody would like to share this? His opinion on what's the meaning of these 2 bullet points? Probably no one, right? So in a nutshell, see, as a programmer from your ICS 102 days, you know, sometimes you will not change the location where the values are being stored. You only, you know, go and location is not changed. You change the values at the same location. But sometimes you actually also change the location, the reference as well, and there the new values are stored. So these all things happen. And as a designer, I should know in what type of object this happens and in what type of objects it doesn't happen. And it's a very important thing for me to know. And I'll show you very shortly why. So basically, let's look at the example, and hopefully this example will make it even more clear. I'm pretty sure from your ICS 102 days, you have been using a lot of string manipulation, correct?
Yes.
Right.
Yes.
So what will happen in this program? What will be the output of S after this line?
AB.
AB, right? Now, what do you think? When this line executed, an object was created, correct? Because it's an object type, correct, right? It's not a primitive data type, right? String is not a primitive data type, correct?
Yes.
So
Yes.
an object was created and the value of that one was A, right? Correct? After this line.
Yes.
Now, after this line, what do you think has happened?
The old object was destroyed and the new object was created.
Everybody agree to this?
Yes.
All right. Absolutely spot on. All right. So when you do a string manipulation, an object was created for this line, and next time when you do an append on it, basically a new object is created. And if you keep doing manipulations every time, a new object will be created, right?
Yes. This is changing the pointer, right?
Yes, so this is basically an example of an immutable, or I'll hold on to this. I'll show you very shortly. Right. So basically, string is an example of an immutable type, right? Remember, we just had a look at the definition of mutable on Google, and it said what? Something which changes, right? So string, as we just saw here, string. Whenever I have a manipulation with string, I'm actually not changing the original object. Every time I'm creating a new object. Right? So string is an example of an immutable type. And basically what happens here is that since it's immutable, it's basically an example where the values can never be changed once they have been created. Right? And immutability actually is a major design decision. Design principle is something very, very important. We'll talk about it very shortly. But everybody's on board with me here now, or for this bullet point? That string an example of an because in an immutable type, once a value has been assigned, whose value can never be changed once they have been assigned or created. Like in this case, right? Once an object has been created, a value has been assigned, it can never be changed, right?
Yes.
In the next line, when you say S is equal to S plus B, you actually go on and destroy this new one. So string is an example of a immutable object. Everybody on board with me on this point?
Doctor,
Yes, please.
is final integer is immutable object? Because
Right.
it is a primitive type.
Yes. So now hold on to that one for me, right? It's a good observation. I'm just going to talk about this as well, right?
Doctor?
Yes.
Actually, I didn't get it that much.
Fair enough. No problems. I'll repeat it. Don't worry. I'll repeat it again. So let's look at it again. Now, at the low level design decisions, we need to worry about whether my objects are mutable or immutable, right? And why we'll talk about later. But let's in this slide only focus on one thing. That string, I'm showing you an example of a string. Now, string, first of all, do we all agree that string is not a primitive data type?
Yes.
Right? We all agree that string is not a primitive data type. Hence, it's an object, right? It's an object type. Now, with this, I'm saying that when I write this line of code, this first line of code, what happens? An object is created. So string S is created and whose value is A. And when I go on and write the second line of code, there were two options. One was that this was changed itself. But in string, because it's immutable, this means this does not change because once the value has been assigned, it does not. What happens is that this is destroyed and a new object is created whose value is now AB. Is this clear now?
Yes, it's clear now.
All right. Great, great. So this slide is actually just summarizing what we just said. so that when you come back you can refer to it. So string an example of an immutable type. This means what? Since it's immutable, by definition it means it cannot be changed, which is the case in string, that once a value has been assigned, it can never be changed, which was happening here, that once a value has been assigned in this line of code, now this value can never be changed. If you make a manipulation with it, a new object will be created and it will have its own value. So immutable objects are, of course, I'm pretty sure you might have noticed in the previous diagram. In a snapshot diagram, they are usually referred as double borders, right? So in this diagram, for example, you have double borders. And so the moment you're going to see a double bordered object in a snapshot diagram, it will tell you what? That this object type is immutable. Correct?
Doctor, are there objects that are immutable?
Sorry, we lost your voice. Can you say it again, Turki?
Are there objects that are immutable?
Yes, exactly. And I'm going to show you one very shortly. Right. So, as I said, the double arrows are shown here. So double borders basically, graphically it tells me that at the moment I see this and I'll see a double border here, it telling me that string is an immutable object. Right? This means every time I I manipulate the string, any manipulation I do, I'm actually creating a new object. Let's look at an example of immutable object as just Turki asked. Anybody has used string builder in Java?
I didn't.
Fair enough. Anybody has used string builder?
Yeah. The string builder.
So that's good. But overall, I believe most of us have not used it, which is okay. And actually, this is my whole point, right? And inshallah, I'll talk about this very shortly. So we have something called string builder in Java as well. And it is an example of a mutable object. So when I say string builder is an example of a mutable object, it actually means what? That when I'm going to write a code like this, that I'm going to create a string builder object SP and its value will be A, and now I'm going to use the append method which is built into string builder sp.append B. How many objects I'm creating now?
Only one.
Only one. See? So whatever manipulations I'm doing here, I'm actually not creating. Every time I'm not creating a new object, I'm just appending or changing the same object because string builder is an example of a mutable object. The question is, why I should worry about mutable and immutable objects? What do you think now?
Because we have limited resources in our devices, so we should worry about it. Immutable objects or immutable types that take much more resources than mutable, I believe.
Absolutely, so you're spot on. Anybody else would like to make a comment on my question? Yes, Khalid, go ahead, please.
The question here, the output is AB, right?
Yes.
Okay, this because of append or because we call it the string builder?
Okay. Now, the output here is AB. Output in string was also AB, okay? So from an output perspective, we're getting the same behavior. But because we are using string builder, and string builder is an example of a mutable object, when you do first you create an object, and then whatever manipulations you do on it using the string builder method, you are not creating new objects every time. Because string builder is an example of a mutable object, the same object is being updated. While in the string, because string is an immutable object by definition, every time we make a change, the output will be still the same. AB will get AB, as was the case happening in the previous one, right? But every time I do a manipulation, I create a new object, which means I'm actually consuming resources here now, right?
Right, Doctor. Okay, if we just I add also append C, so the output will be ABC.
In the string builder.
Yes.
True. Yeah. So if I append C here, so if I call an SB dot append C, what will happen? Will I create a new object?
No, you will add also C to AB.
Exactly. Now, while we go back to the string here, if I add S equal to S plus C, what will happen? This value will be changed or a new object will be created?
New object.
Yes, a new object will be created. And now its value will be ABC. Khalid, this is clear?
Yes, I got it. Thank you.
Great, great. So everybody is able to understand why is as a designer it's so important for me to know whether an object is mutable or immutable, because with an immutable object like the string, and as you know, probably most of us have been using strings from day one, and we don't really explore or never explored that there's something called string builder there, because it's our work and it's doing the same thing. But as a designer, this is important for you to know that whether my object is mutable or immutable, because if you are working with limited resources, if you are working and developing an application for mobile applications, and you're designing an application which has so much string manipulations, right? Now, what is an advisable thing to do as a designer? Should I go with a string or a string builder?
String builder. Because you have
Exactly.
many manipulation.
You have so many manipulations and you don't want to unnecessarily create so many objects and basically resourcing or wasting the resources, and those resources are limited anyway for you on a mobile device. So this is an important point for you as a designer to understand. This is such a critical thing. Everybody is comfortable with the concept, right?
Yes.
Alhamdulillah. Perfect. Now, this brings us to the next level, which I believe doubt about the final, right? So we have something called immutable references as well. So far, I was only talking about immutable and mutable objects. Now I'm talking about immutable reference. So just kindly keep this in mind that here I'm talking about immutable reference now. So Java also helps us have immutable references, which means basically variables that are assigned once and can never be assigned again. How we do this in Java?
Final.
Final, exactly. So we use the keyword final. And basically what this is telling me, this is telling me that, since n is a final, this means I am telling the program now is my immutable reference that, once the variable has been assigned a value, it can never be assigned again. Hence means it's immutable. It should not change, it's not changeable. So if the compile, of course, I'm pretty sure all of you have seen this from even your ICS 1 or 2 days, early days, that, once you define a final, if you try to manipulate this value of n again down the road in your program, what will happen?
Error.
Compiler will throw an error, and compiler will throw an error because it's continuously statically checking for your immutable references, because here you have now defined that this is immutable. It cannot be changed. Hence, it's continuously statically checking your program saying, n should never be assigned a value, n should never be assigned a value. Every time you do something with n or any other variable, it will make sure that, it's not assigned. If you assign it again, it will just throw an error. So from a conceptual perspective, are you clear now that there is a difference between immutable objects and immutable references?
Yes.
Great, great. The word immutable has the same meaning. It has the same impact. But when we talk about object, it means you are not able to change objects. With references, it means you cannot change variable values. So graphically, if you look at this diagram, though I have not explained one or two other symbols, probably one symbol at least. This diagram, what it tells you as a designer.
This is a mutable object.
Yes, so person is a mutable object, so it can change.
It has two attributes, ID and age.
Correct. And what about the references now?
The first one, I didn't know about it.
The second one, the age.
It's just primitive type, integer.
So is it changeable or not?
It's changeable, absolutely.
Right. What about the ID? What do you think? Though I have not explained it, what do you think about ID?
Not changeable.
Not changeable
I
because of
think
the
double-lined arrow, yeah.
Exactly, exactly. So see, in this snapshot, we are referring to a mutable object called person, right? It has two references or variables in it. Because of the final, right, ID, if I make it final, this means this cannot change. So it's an immutable reference, okay? While the age can change, so that is a mutable reference. Got it?
Yes.
And see, the strength here is that using a very simple graph, you can communicate, and all of us, can understand it in a very simple way. Now, any questions on this, guys? Yes, please go ahead.
Why isn't string builder the default string?
Again, Turki, can you repeat the question?
Why is string builder not the default string?
Turki, I was not able to hear it clear. Can you type the question in the chat box, please?
Okay.
Thank you.
I think he says why the string builder is not the main string.
So it's why the string builder is not the main string. Or in other words, if I understand correctly, you're saying that why we use string by default and not string builder, right?
Yes.
Okay, so yeah. So if the question is that why we use string builder as a default, not as string sorry, we use string as a default, not string builder, is this is the whole idea, or this is the whole point of my today's lecture, right? That in the beginning, the Java gives you both options. In the first introductory programming language course, they use string because at that stage you don't worry about resources, you don't care about any of these constraints. But now, mashallah, you guys are all mature, a lot of programming experience, you know the fundamentals of design now. Now this is the point for you to start thinking about, do I always have to go by a default data default, or a popular one, or I have to carefully think that, in my application, in my given system, what is a right way of doing a certain action? Like, should I go with an immutable object because I don't really, maybe I need them, or maybe I don't, I don't worry about the resources? Or should I go with a mutable one like string builder because I'm gonna save the resources? Again, that's why Java provides both. This is a time for us as designers to understand the concept. Mashallah, you guys are mature now. So this is what exactly my message today in the lecture. That I want you guys to now start thinking about that we should think about, especially where the cases where you're going to have a lot of issues with your resources, especially on mobile applications, you know, where the cost is important for you from a computational perspective. Why I should be using string? Why I should not use string builder? Of course, my recommendation will be use string builder. It does the same thing, and it helps you to save the resources. Now, I'm pretty sure from a data structure perspective, the same thing is there, and probably you have gone through this already. That so for example, certain kind of sorts are more costlier than others, right?
Yes.
All right. So this is exact the same thing. Here, I'm trying to now get you guys aware about this point that we should not be just going with default, or we should not be going with something which is popular. Because in a normal application on a desktop, probably, or where you are not doing a lot of manipulations with strings, probably, using either one of them will not make a huge difference on performance of the application. But if you're aware of these concepts and you are in a context now where you have a lot of string manipulation in your code and you have limited resources, then we should be carefully thinking about which of these two, for example, in this case, I should be using. Is this more clear now, Turki?
Yes, thank you.
Thank you. Any other questions, guys? This is the whole idea why I bring this today. I want you guys to be aware of this now. Are we clear about the concepts about mutable and immutable objects and mutable and immutable references?
Yes, inshallah.
Yes.
Inshallah. They're very simple concepts, but as long as we are aware of them, this is what I want you to know as designers. Now, just to complete the discussion, and someone can always ask me this question, so I just usually bring this one up here, is that you can have an immutable reference to a mutable value. This is allowed. This can happen. So for example, you can say final string builder SP. String builder is what? A mutable object, right? And when you make it final, you're doing what? You're making it an immutable reference. So it will mean what? Technically, it will mean what?
Immutable. In the end.
Immutable, right? So basically, it will mean that you create an SP object, correct? Now, since you make it final, can you append to it?
No, you can't. I believe.
Exactly. Yeah, we cannot because you made it final, hence you made it immutable reference. Okay. So this is possible. Now, question is, should I use it or not? That's a different ball game, right? Or what's the benefit of doing this? That's another thing. But from a programming perspective, from a Java programming perspective, you can do it. What about the other way around? Have a read of this bullet point. By the way, this is by default, by the way. This is what really happens anyway when you do a string manipulation. Anybody would like to make a comment on what I'm saying here?
I think it's clear.
It's clear. Everyone is on board with me on this point.
Yes, it's clear.
It's clear.
Yes. Yes. Exactly. Good. Alhamdulillah. Well, this is straightforward anyway. Right. So. Now, this is first thing I wanted you guys to know today, right? And so that you have a clear understanding of this important concept in design. It's usually at the very low level design at a runtime, right? These things make difference if you have resources limitations and so on and so forth. Now this brings me to the another important aspect with reference to software construction, which is your specifications. Now, I'll just give you, a bit of introduction to it, right? We'll not be going into a lot of details about this today. Inshallah, we'll continue this on Sunday. So, but before that, let's look at what I mean by specifications. So, it's a fact that when we integrate different piece of codes in our applications and large applications, because different developers are developing them and they could be in different teams or within the same team and so on and so forth. A lot of bugs happens or failures are there because of the faults which are there at the time of integration of code. And we usually have these difficult faults introduced into the program due to misunderstanding about the behavior of these different pieces of codes we are integrating. Have you ever experienced this? Even in your own programming projects where multiple programmers, developers are developing applications.
Yes, we have. Of course we have.
Of course we have. And you will see this in your senior projects where 5 or 6 team members will be developing code, right? Unless you pay special attention to this. So usually, and this is true in the industry as well, that whenever you have different piece of codes developed by different people, if we have misunderstanding about their behaviors, which means what kind of parameters it will accept, what it really does, what return value it gives, why there is a void or not. If you have a bit of misunderstanding about this, you can introduce faults, and those faults can be very hard to track. So, but having said this point, this is also a fact that every programmer who is writing a piece of code, he does his best or she does his best to write it in the right way. Nobody wants to introduce a buggy code or release a faulty code into the production. This is not an intention of a programmer. So everybody has, and when he writes a piece of code, he has some logic in his mind. He understands and he's thinking about what this program will be doing, what inputs it will take, what exactly it will carry out, what it will return. So there is a spec in your mind. Specs are there in your mind, but this is also a fact that not all programmers write them, correct? I'm pretty sure you have seen this as well.
Yes.
Right. And since they are not written, you actually, as a result, come to this issue where you have misunderstanding about the behaviors. So as a result, different programmers on a same event team can have different specs in their mind for a same piece of code. They may completely anticipate in a different way. They may expect it to do completely different things. And if they are not clearly specified, we are calling for trouble. And usually these troubles happen as a result of faults, which lead to failures. And of course, it leads to problems in debugging and trying to fix these issues. So of course, what happens here is that if you have misunderstandings, then when the program fails, it's very hard to determine where the error is, right? And especially, then you may say that whether these two unit of programs which were integrated, whether they are faulty, fault is here, they're individually fine, but something happened in the middle, the fault is happening here, it's a question mark and it's a challenge. And usually, if you have precise specifications for each part of your code, which could be a method or a class. So if you have a precise specification, it will help you do what? It will basically let you get away with this blame game that, Ahmad, you wrote this bit, or Muhammad, you wrote this. There is a mistake on your side. You basically, get away with all of those blames and everything, because every method has its own clear specification, and if there is a fault happening, there is a failure happening still, you can have a clear understanding on how they have been integrated, right? And then you can go on and fix them. So specs are very, very important. And of course, good specs are are amazing in a sense that if you have a good specification as a client of that program. So if you have a good specification written for this piece of method, and you're going to use it, you all have to do is basically read the specs. You don't have to even understand and read the code, because reading a code is hard, isn't it? But reading a well-structured, clearly defined, precise specification will make your life very, very easy. Everybody's on board with me on this.
Yes.
Okay. Now, I think we can stop it here, but maybe I can show you this example very quickly. If someone is not still convinced that specs are clear specs are important, can you make a sense of what's happening here? This is Java 8 source code from one of the methods.
It is hard to understand what he wrote.
Exactly.
It will be like you will rewrite it again.
Exactly, and so on and so forth. So probably let's use this as a good stopping point, inshallah, and we'll use this slide as a starting point, inshallah, after the weekend on Sunday as well, to talk about why specs are important, and then also how to basically write them. So let me stop the recording. It's 10:50 now, so let me stop the recording and take attendance. And of course, floor is open for any questions, please.